I'm going to pick up right where I left off. So in the last lesson, we talked about kind of the core functionality and data of how Houdini represents geometry versus how Houdini represents imagery and that stuff. And we have come out with this. So this is basically me rasterizing my original position into an image. If you don't want to go through all this and you don't mind some seams, or if you just want to get your feet under you, feel free to use the rasterize geometry and everything will be good. Okay, so now, so I have my position. So now here, if on my out patch is the next part, I need to somehow transfer this UV information over to this information, or more importantly, this information. This is what was very, very difficult. And I did find, I can't remember the gentleman's name. I'll put the link in the video. There was a great, like it's kind of buried inside of his video. He was trying to get geometry to, he was trying to get his geometry from Sopland into cops. And there was this one part in there that was very, very compelling. And he did it with a wrangle. So lots of wrangles today. So basically in this wrangle, I'm taking in two pieces of geometry. The first piece of geometry I'm taking in is this, my original geom, not the rasterized geometry, the fully realized geometry. And I'm also bringing in my patch, right? That makes sense, right? Because if I want to transfer something from one object to another object, I need to have both of those things, or at least have access to them. So that's input one and input two. Those are two geometries. So this pink salmony color means geometry. The next thing is I'm bringing in that original position, right? I want that position of my original pig head mesh. But what I want is I want to sample this information in raster space, not in vector space, because my raster space, I can change my raster space. So this is how you can change your texture map resolution, your texture set resolution, and everything kind of stays the same because it's just resampling from these images. This is also why in Substance Painter, I usually bake my mesh maps at the highest my computer can handle, just so I get that fidelity. So that information isn't coming out. So I'm getting my 2 bits of geometry, and I'm getting that original position of my pig. So what's happening here? This one's a little bit more complex, but it's pretty much the same thing. It's all driven by that xyzdist and the primuv. So if you don't understand this, or if you found this in the middle of the series, go back to the video before this and I explain how all that works. Hopefully I'll be able to explain it here too. So first thing, I'm getting a vector, right? Orig_p, because that's its position. It's x, y, and z data, right? So this, my orig_p, is coming into my pigP. I should probably rename that because I'm not going to be working with the pig all the time. But this is my pig positions, is my orig_p. So same thing. I'm making an integer. That's going to be the primitive number. And I'm making a UV data. So I'm calling this patchPrim and patchUv, just so I can remember what's what. And then I'm grabbing a depth value. So the CH depth, it allows me to have this depth. So if the patch is too far away from the surface, it won't project, right? So this is just, it's a sanity check. So that's the depth. So I'm going to use these once again in xyzdist. So once again, I'm making dist. I don't actually use this, so I could get rid of it, but I like to do it. I like to have it if I need it. So the xyzdist, this time I'm taking the second context geometry. So in the first time, in last lesson, we saw I was grabbing the first context geometry. This one, I'm grabbing input 2. What is input 2? Input 2 is my patch information. So I'm grabbing that geometry. And this is, once again, I can't stress this enough. Having geometry directly accessible in your texture software is mind-blowing. It's such a good idea. For many, many reasons, but for this reason, it's like I'm texturing with information and in with data. So it takes a little bit more brain power. You can't just click, click, drag, drag, swipe, but it gives you ultimate control. Okay, so, and then my first input, I don't even think I use the first input, but it's good to have anyway. So that second input. So I'm taking, what position am I sampling? I'm sampling at my pig's original position, right? Because if we remember, my patch here and my pig are relative to each other. They're close to each other. So I'm saying, hey, give me the primitive of my patch, right? Give me that primitive number, and then give me the UV, like we talked about before, the location on that face. So when I say primitive, in all of these cases, you can kind of interchange primitive and face. So I'll kind of use those interchangeably. So I'm saying, give me the face on the patch that is closest to this position in space, and then give me the position, or give me the UV information from that face. And then if it's beyond this depth, just send me back nothing. Okay, that's what that line does. So just like the analogy I had last time, where so I've gotten the location of my store. This is Google Maps for Houdini, right? So I've gotten the position of my store. I've gotten the location of my store. Now I need to go pick up the information from that store. What information do I want to pick up? I want to pick up the UV information from my patch, right? I want to pick that up and I want to encode that into whatever pixel I'm working on. So that's how COPS works. It goes through each pixel and it runs this code for every single pixel across this image, or across this height field, as we call it, or field, or whatever you want to call it, this rasterized data, right? So it's going this one, this one, this one, this one. And actually, it's actually not doing that. It's doing them all at the same time because they're not dependent on each other. And that's what makes Houdini so fast. It tries to do as much stuff at the same time as it possibly can. And it's completely multi-threaded, which is bonkers. So I'm picking up that UV information, right? So I have this patchPrim, patchUv. Now, that's giving me that UV information. Now I'm just spitting this out as C here. So here I'm spitting out RGB and I'm spitting out C, and I'm just saying set. So this is making a UV.x, result UV, UV.x, UV.y. And because, like we talked about last time, I don't really use the W, I just set that to 0. Now I could perhaps, instead of doing all that, you could just spit this out, because most of the time you're just ignoring everything. So I could say, let's just do at C equals result UV. And I should get pretty much the same. Yeah, so pretty much the same result. I'm just getting that blue value in there. So I didn't want that blue value in there. So I'm basically making that W vector 0, right? So this is one of the other big hurdles that I found, is like, you look at this and you're like, is this working? Because it's just raw data. Like our human brains aren't designed to look at raw information. We're designed to look at the output of that information, or the result of that information. Here, we're just looking at raw UV data. So how do we use this, right? Because we have this UV data, just like on geometry data or anything else, this is just data. So I can take this UV data and I can say, hey, take this picture that goes from 0 to 1, right? So let's say take some picture, any picture. This goes from 0 to 1, and this goes from 0 to 1. Remap this to this, because this is also all going from 0 to 1 by the color. So looking at here, this is very, very bright red. So that would be somewhere probably down here on my UV map. This is incredibly green, so it's probably somewhere up here on my UV map. This is pretty yellow here, so this is probably going to be somewhere around here on my UV map. So I'm basically taking whatever color is here and I'm going to put it there. And whatever color is here, I'm going to put it there. And whatever color is here, I'm going to put it there. So basically I'm taking it's almost like a transporter if you're a Star Trek fan, right? I'm taking this image, I'm breaking it down into its component pieces, and I'm moving it based on rules to another space. The way we do this is with a node called UV sample or texture sample. So here, I'm taking this color. So this is color information. I have to change this into UV information. We have this converters. Now, why do I have to do this? Why can't I just take the image data? And this goes back to what I was talking about the last kind of dev blog I did, is that in Houdini, images, quote unquote images, are fields, right? So it's a flat 2D field. Like, so if you've ever done volume stuff, so like smoke, fire, you have these voxels, right? And your voxels have to have a type. So the voxel either has to be like a type integer or a type float or a type vector. You have to change them from one thing to another. So right now, this field, this 2D field, is color. I need to change this color information into UV information. So that's why I have this UV to UV1. There's a bunch of these. There's like RGB to mono, so basically taking a color image and turning it to black and white. Mono, like there's all sorts of converters, right? So you really, really need to pay attention to these colors. And I haven't really committed these to memory yet, but I do know by doing these examples that the salmon color is geometry. This kind of green tealish color is color, is a color with no alpha. There's also let's see, where is it? I'm getting ahead of myself, but there's different types. You have to make sure that you're using the correct type for what you're trying to do. So in this case, I'm trying to use UVs. Okay, so now we have our UV coordinates. If I do in here, like if I go back and forth between here, they don't really do anything because it looks exactly the same. I'm just saying I'm re-tagging that data from color to being UV. Now, texture sample. This is where the magic happens. So basically, my texture sample takes my UV information, which I've generated here, which I've pulled from my patch and put into the pig's UV space, and then it takes a texture. So if I grab here, right, it's just taking whatever comes into this. So let's ignore this multiplier for now. I'll get into that in a minute. So whatever comes in through here is my texture. So in this case, so let's just do a tile pattern here, and I'll just kind of rebuild this. So let's do tile. So this is one of the built-in UVs. And if I take this tile and let's set its signature to, let's say, tiles, and let's plug that into texture. And if I look at this, I'm seeing that tile projected down onto that. And that's amazing, right? That's really, really cool. So we'll just stick with this tile pattern here as an example. Now this texture is in my pig's UV space. So by default, the tile spits out a monochromatic image. So it's just a black and white image. And I want to put this into color, or into my base color. So I need to say, so I'm going to say out RGBA. In this case, I really don't need, yeah, so I need RGBA to RGB, and then I will plug that in there. And so now I have that texture pattern on my pig. So if I go back up, so when we go out to Copernicus, this is the great thing. This is all live. It's all connected. It's all completely connected. So if I come into here and I move this around, that patch is going to move around. And because it's projected to an extent, it's going to try to stick to the surface. So if I look at down here, so I slide this around, I can see that projecting onto the surface. And I can still use my tilde, and I can snap this up here, and I can use R to rotate this, which is really cool. So if we come back to Copernicus, that all adjusts, which is fantastic, which is great. So the last thing that I'll go over is what that multiply is doing. And this is kind of like just like a sanity check, basically. So let's plug this back into here. So I get this, this noise pattern. And this noise pattern, once again, I'm planning to build this into an HDA at some point. So I like to be very explicit about my inputs and my outputs. My input for this HDA, or even like a recipe, maybe they introduce the recipes in 2025, or both, who knows, you can do both. So I have this in texture RGBA. And so over here, I have the switch, and this is just for testing purposes. You wouldn't do this as a switch, but I could just plug this, like let's plug in this herringbone, plug it straight in, and now I get herringbone. Or if I just want a solid color for a mask, I can plug that in. This is a procedural texture. I can plug that in. And even I can plug in a file texture. And so now I'm getting my little default butterfly. If I wanted to grab something off disk, let's go grab, I have like this cheeky egg here, this egg, green eggs and ham. So now I have this, he's got egg on his face, quite literally. And it's all connected, and that's amazing, right? So one thing that I did run into was with this herringbone pattern. Let's just go straight from this transform 2D, and we'll plug that into my texture. I got this, like there's this kind of like the smearing. If you've ever used Nuke, you may have seen this before, where you move something and you get like this repeatingness everywhere. So I want that. It's going beyond the edges of the patch. And that's mostly probably because of this transform 2D. Now, what is this transform 2D doing? This transform 2D it allows me to slide this information inside of that UV. So if I start to rotate this, now I'm not rotating the patch, I'm rotating the information inside the patch, which is super cool. I can scale this inside the patch. If I wanted to repeat, right now I have my border set to clip. I can say auto, and that will just keep on repeating over and over and over again, which is really, really cool. But the problem is I'm getting like this outer bit. Like you can see it's starting to flicker because it's different parts that it's sampling on. So basically what I want to do is I want to make an alpha map. It's quite small. I want to make an alpha map that cuts this off. The beauty of this, and I keep saying the beauty of this because I'm super excited about it, right? Is that like this is a square space that's being projected onto the pig. So whatever I do in this square space will be projected on the pig. So it's much easier to manage your data when you're just working in a square instead of working out in this kind of crazy projected space. So to fix this, what I did is I kind of replicated a node in Nuke called black outside. So it basically multiplies like one little small sliver around the outside so that black outside, that one pixel kind of bleeds out everywhere. And I just made a constant here, just a white constant, and I did a UV transform and just transformed it down like 0.99. You could be really you can be much more precise about this to figure out, you know, how big your image is, to like what value would be just one pixel around the outside, but this is kind of like a proof of concept. So I just left it like this. And then I blurred it just a little bit, or I could blur it just a little bit here if I wanted to soften the edge of this. I could even do a scale if I wanted to kind of erode this alpha inwards. I could do that. So basically what I'm doing is I'm taking the result of this and I'm multiplying it by my edge. So you can see that that edge is being chopped out there. And so that's where this multiplication is coming from. So now if I do my blend, let's go back to my pig head here. So if I take my multiply instead of just a raw texture and plug that in there, I can do that. And now with this, what I can do, like I said before, is I can erode in if I wanted to. And I can also, with this blur, I can do a fade. So I can now fade this in and out. So you do have to make this fade value quite large. And eventually you will hit the edge. So if I've gone too far to the edge, then I have to come back into my uniform scale and bring this down. So if you wanted like faded anything, right? So it gives you this ultimate control, right? So let's go back to our regular one. And let's get rid of this tile pattern. So I have my texture sample just to make sure, like if I'm going to, this is out RGBA, I should probably just call this like out something, because it may not always be RGBA. It might just be, you might just be working with mass data, so just black and white information. Those are probably the two main things. Mostly I'm planning on using this for masking, just like I do in Substance Painter. So to put this into my base color, I might be able to just put this directly into my base color. Yeah, it'll do the conversion for you, but it's always best to take my RGBA and just convert that into. So yeah, that's mostly it. It is complicated. I'm not going to say this isn't complicated, especially if you haven't done this type of work before, but it's worth it. It really is worth it. Like anything that takes a little bit of grind to make and to do, if you can figure out how to replicate that grind, that's what brings value. Like things that are just like one-click solutions, that's why you pay for those, right? Because they're giving you time back. But if you're the person that makes that stuff, that's a revenue stream. That's amazing. So the last thing I'm going to show is something that I always say about Houdini, is that what works for the one works for the many. So I have this out patch. So instead of projecting it straight away and transforming it straight away, right? This is just set at the origin. So instead of using this guy here, I'm going to use a node that I'm kind of ashamed I just learned about. It's called it's the labs place pick and place, I believe it's called. And it takes a geometry and it takes a collision object. So what I'll do is I haven't really tried this yet, so I'm hoping I don't put my foot in my mouth. So I'm going to say pick labs pick and place. Let me save this before something horrible happens. We'll call this 3. Right, we have this labs pick and place, and in the first context, we want our collision geometry, so that's going to be our pig. And in the second context geometry, we want the geometry that we are going to place. So here. So I come to here, shows me my pig, and it also shows me, if I press enter, if you don't see this, press enter, and you'll get into the mode. You can see that this thing is now, so this feels now to me, this feels a lot like that surface tool in Substance Painter. So I can click here and click here, click here, click here. think you might have to be on a face. Yeah, it feels like you have to be on a face, like you can't be on an edge. So I'm just gonna kind of scatter these about. So I have, let's press escape to get out of this. So I have all these projections now. And the cool thing about this is it has this ID that's coming with it. So let's say you wanted to scatter a bunch of these around, and on some of them, like on IDs, on like every other one, you want one picture, and every other one you want another picture. You can do that with these IDs because you can split stuff out in Copernicus by ID. I'm not going to get into that now, maybe in a later lesson or later experiment, but it's possible. And that's the thing that's really exciting about this. You have these tools, you have these building blocks, and once you build one thing, you're like, oh, I could use it for this, or I could use it for that, or oh, I could update this process. It's really, really exciting. Okay, so this has two outputs. I'm gonna right click here and I'm gonna say actions and go to flags and output view. So this is, I'm viewing output 1, and output 2 looks to be just the patches. So if I plug my output 2 into here, this out patch, so now this is going into my Copernicus node. Instead, I should get, yeah, so now I have all those little patches all over my pig. Now this is amazing. You don't have to use this pick and place. You could use a scatter to do this. It's very, very powerful. It seems really dumb that I'm just making like these little patterns all over this little pig head, but if you think about like the how powerful this is, like I've basically rewritten a tool in another software in Houdini, in Cops, because they're not hiding any of that information from me. They're like, here's all the information, do with it whatever you want. In the next lesson, I'll try to do the scattering setup. So if that fails, you can see why it fails, and you don't have to go through this whole video because these are getting quite long. So yeah, so I've been talking for about the same time as the last one. Yeah, so this is really, really exciting. Like I don't know if you're excited about it, but I know I am. Like, and it's only going to get better. It's this is still in beta. Like this is beta. Like this is like when they give it to you and they're like, we don't know if all this is going to work, and it's like it's amazing. So good guy side effects. All right. So I hope you enjoyed this. I hope you got something out of it. I hope you're learning a little bit about data and a little bit more just about how CG works. So yeah, hope you enjoyed it. I'll see you in the next one.